applies before you even look for absolute maximums or minimums. Okay, so remember, for the extreme value theorem to apply, for it to guarantee that there is at least one max and absolute max and min in that closed interval, it must first be what? Continuous on that closed interval, okay? So looking at this first one, can you tell me where it's not continuous? So we know that this guy is not continuous at x equals -3. Why? It's a vertical asymptote, right? Okay, what else would I have to check? For holes, does it have any holes? No? Okay, what else would I have to check? That -3 is where? In the interval. So is -3 in this interval? Yes. So does EVT apply in this particular case? No. So what do we say? EVT does not apply because h of x is not continuous at x equals what? -3, which is in the interval -5 to what? I can't apply the extreme value theorem. I can't look for the absolute maximum and absolute minimum in that interval because the extreme value theorem does not apply. It's not guaranteed that there's going to be at least one max and one min. Because it's not continuous. How about this one? Where would this one be continuous? This is where this one is not continuous, right? When I have a square root function, I want to find out where it will be continuous. It's going to be when the numbers in the square root are 0 or what? Positive, right? So it's going to be where this guy, x minus 3, is greater than or equal to 0, and that's going to be where? When x is greater than or equal to 3. So now when I check my interval up here, what do I discover? Are these numbers greater than or equal to 3? No. Okay, this is from 0 to -5. So does the extreme value theorem apply in this case?
Yeah.
Yes?
No, we know.
No, it does not. This is where it is continuous, Pablo. So that means if it is continuous here, that means that in there it's not continuous. You understand? EVT does not apply because g of x is
Not continuous?
not continuous?
Oh, no.
Is continuous?
Just said it was.
For what?
Oh.
X's that are greater than or equal to 3, which is not in the interval -5 to what?
You just state that it's not continuous.
You just state that it's not continuous?
From -x to 0?
Yeah.
I could always think that's one.
Yeah, that would be cool. I just want to be more specific.
Yeah.
Like weird.
How about the last one? This is one of the ones you didn't think of. The ln function. When is the logarithmic function defined or continuous? The number inside, the argument has to be greater than 0? Can't equal to 0 in this case? You can't get ln of 0? Why not? Why is it undefined?
You can have like
Oh, so this is implying like e to something has to equal 0? Oh, that never happens? What if I have like a -5 in here? Is that possible? Will e to something ever equal a negative number?
No,
No?
no.
Wow. Okay. What happens if I have even if I have like a negative power? Doesn't work? E to the negative 1000? Still positive? What? Imagine. E to the negative 1000. That has to be negative. What is that the same thing as? 1 over e to the 1000, which is a positive number, right? It's a really small number getting really close to what? 0, but never equal to it, right? Or never below it. Okay, so in this case, this guy is continuous wherever this inside, x plus 7, is greater than what?
Are you kidding? Okay.
So that would be when x is greater than what?
-7.
Negative 7. So check the interval, Alejandra. Are these values here greater than negative 7? Yeah? Negative 5 is more than negative 7? You sure? Okay. So, does EBT apply for this one? Yes? So what will you say? EBT does apply because f of x is continuous for x's that are greater than negative 7, which is
You'll punch me.
on the interval negative 5. So this is one important thing to check before you take off and you start finding your absolute maximums and minimums. Is check to see that the function is continuous on that particular interval only before you jump off. For example, if this would have given me negative 3, I know that's where it's not continuous, but if it wasn't in this interval, would I still be able to work it out? Would I still be able to find the absolute maximums and minimums? Let's say it was only from negative 2 to 0. And will we still be alright? Yes. I'd still have to find the first derivative of that. I'd still have to find the critical numbers, test those and the endpoints in the original function. Understand? As long as it's continuous in that little interval that they're giving. Got it? Is that enough, or do you need me to do like a full example? Full example would be good? Yeah? Alright, so look at those last 4 and tell me which one you want to do.
Oh, yeah, do always someone
And
close.
if we don't do them all, well then we'll do one tomorrow to get warmed up.
Number 2.
Number 2?
Two
We
and
can't do that here.
No, let's do
I'm
it.
just kidding.
That's number 4.
Ellen?
You got it.
I like Ellen.
And then,
Take a
You
vote.
want Ellen?
no, that's 2. I thought you said 2. You
No,
said
let's
we're
do
gonna
4.
do like 2.
4.
2 and 4?
Yes.
Alright, let's do 2 and 4. Alright, so let's read the instruction.
I was like, no.
Given the functions below, determine the absolute extreme values. What are they asking me to give them? The whole point?
Oh, no.
Only y. Would it be okay if I still gave them the point? You think they'd still mark it right? Yes. What if it was like multiple choice and they put the x and they put the y separate?
You go for the Y.
Then you have to be very careful and make sure you pick the right one, right? Okay? You have to know the difference, okay? If they say absolute extrema, you're finding the whole point. If they say extreme values, you're only looking for the y parts. Good? Provided that the extreme value theorem is applicable. If it is not, state specifically why it is not. So looking at number 2, okay, we first have to check what? Check for continuity. Okay, so is g of x continuous? No? It is. So it is continuous on this interval, pi over 2 to 2. Alright, so now we can take off and we can find its derivative. So let's find the derivative of g. How do I have to think of this to find the derivative?
Sin of x squared.
The whole thing to the second power, right? I have to think of it that way also when I want to type it in my calculator, okay? Don't try to put the 2 there because it won't work. You gotta put parentheses and square the whole thing. Alright, so let's do it. We gotta do chain rule. So what's the derivative of that first part? 2 times sine of x times the derivative of the inside. What's the derivative of sine? Cosine. And then, what's the derivative of cosine over here? So minus sine of x. We okay? Now we need to find our critical numbers. How are we going to figure out where 2 sine of x times cosine of x minus sine of x is equal to 0? Did it equal to 0? So 0 equals, can we factor something there? What can we take out? Sine of x? And we're left with what?
Yeah, 2 sine.
2 cosine x minus 1. Okay, and then what do I do? Set each factor equal to 0. So where does sine of x equal to 0, and where does 2 cosine x minus 1 equal to 0? Where does sine equal to 0? Again, only between pi over 2 and 2 pi, including them.
Pi. Pi and 2 pi for sine.
Pi and 2 pi?
For sine.
Yeah?
Yes.
Okay. So here would be x equals pi and 2 pi, you said? Okay. Are we okay? Do we know what we're looking at? Everybody know where pi over 2 is? And 2 pi? We're looking at all this area? Okay. How about the other one? We would get plus 1 divided by 2, so we're looking for where cosine of x is equal to half. Where would cosine of x be equal to half? Let's start off by figuring out where is cosine positive.
5 pi over 3.
All students take,
Calculus.
so it's only going to be positive here, right? Okay, so when is cosine equal to half in the first quadrant?
Pi over 3.
Pi over 3, right?
Yes.
1 over 2. So what over 3 is over here?
5 pi over 3.
Double the bottom, one minus 1.
5 pi over 3.
5 pi over 3? 3 times 2 is 6, take away 1 is 5. Good? Set 5 pi over 3. So far so good? Okay? Alright, so now what do I do?
Again.
Test the values, right?
Yes.
Which values do I test?
Pi over 2.
Test endpoints and critical numbers in the interval, right? So are all those critical numbers in the interval? Yes, we made sure they were, right, when we picked them? Okay, so let's do it. So now I want to find g of, I'm going to start with the first endpoint, pi over 2. I also want to find g of pi. I want to find g of 5 pi over 3. And I want to find g of 2 pi. Hola mole, you ready? So it's just sine squared plus cosine, right? But pi over 2, what's the coordinate? 0, 1, right? So sine squared plus cosine. So 1 squared plus 0? 1? Okay. How about at pi?
Sine is 0.
Pi is negative 1, 0, right? So 0 squared plus negative 1?
Negative 1.
Negative 1? 5 pi over 3, what was the coordinate?
1 pi over 2.
half, comma, radical 3 over 2?
Negative radical 3 over 2.
Negative radical 3 over 2, very good. So that means it's negative radical 3 over 2 squared minus half,
So 3 over 4.
right? Negative radical 3 over 2 squared minus half.
3 over 4.
3 over 4,
5 over 4.
right?
No.
Minus 1 half. So if I have 75 cents and I take away 50 cents, I have 25 cents. 1 over 4. And at 2 pi, what would we get?
1.
1? Okay. What are my extreme values here?
Your absolute.
I got the original one.
Oh,
What is
yeah.
it?
Yeah, there's that's what
That's the original.
one and a half.
Why would you like it?
Or it's like half the
Yes, you test them in the original function.
And how did we get minus half
Cosine
of 5 pi over 2?